Now in this tutorial we're asked to solve the equation 2 sine 2x equals root 3 for the angle x between 0 degrees and 360 degrees. Now in order to do this, you'll notice that first of all I'm not using the angle x here. It's a multiple angle, it's 2x. Now when you get questions like this, what you've got to do is consider a new range. This is for x being between 0 and 360 degrees, but we're dealing with the angle 2x. So what we need to do is create a new range. And to do that, because I am doubling x, I need to double each of these intervals through this inequality. So first of all, I need to double the 0 degrees by doing 2 times 0 degrees. Well, okay, it doesn't seem to change it, so we just put 0 degrees there. But at least I've gone in and multiplied that, or thought about multiplying that by 2. Next, we double the x, so that's 2x. And finally we double the 360 degrees, that's 720 degrees. So we're looking then to solve this equation not in the range 0 to 360 degrees, but in the range 0 degrees to 720 degrees. Okay, let's start then doing the question. So we've got 2 sine 2x equals root 3. First thing I've got to do is remove this 2 by dividing both sides by 2. So if I do that, I therefore have that sine 2x is equal to root 3 over 2. Next, I need to find the inverse sine. I need to do the inverse sine to both sides. So we end up with 2x equals the inverse sine of root 3 over 2. And at this point I always draw the quadrant diagram. So draw the quadrant diagram, draw it over here. Okay. Now, which quadrants do we need to work in? Well, remember this is 0 degrees, okay? This will be 90 degrees, 180, 270, 360. Always put 2 lines in the quadrants where, in this particular example, sine is positive. Sine is positive in the first quadrant and the second quadrant. So we put a line in the first quadrant and we put another line this time in the second quadrant, equally inclined to this horizontal line here. And always get in the habit of marking those 2 angles in, not the ones up here, okay? Always the ones to the horizontal line. Next, we need to mark in the angle 2x. Alright, now the angle 2x will be this one here because that's in the range 0 to 720 degrees. So don't label it x, label it 2x for this example. We next need to start from here again, and we turn now to the next line. So we turn to here, and that's another possible angle that we're going to have, and that will be also another 2x. Okay, so we've labelled the diagram like this. Now, what we need to do is just find out what the inverse sine of root 3 over 2 is, and if you do that on a calculator, although you should know that anyway, it is 60 degrees. So 60 degrees we'll put in. Put a comma there, okay? This is the red angle here. This angle in here is the 60 degrees. So this corresponds to the red 2x. Knowing that these 2 angles are exactly the same, remember I asked you to mark those in at the start. That means that this angle in here is clearly 60 degrees. So therefore the green angle will be 180 degrees minus the 60. In other words, 120 degrees. So that's another 2x. And quite a lot of people just stop at this point. They think that they've got to be restricted to 0 to 360, and that's where people lose out on solutions. But we've scaled it up, we've doubled the x, and we've got a new range. So we can actually go further around this diagram. If we go back to this blue line here, which had an angle of 60 degrees, we can actually go round from there another complete turn. So in other words, we can add 360 degrees to this 60 and get another possible solution. I'll mark that in anyway, just to show you that we're going from, that was the red one, and we're going to the next angle, which is to add 360 degrees. And if we add 360 degrees to the 60 degrees, then we're going to get 420 degrees. So pop that in there. Similarly, we can go to this blue line, okay, the green 2x, which was 120 degrees, and we can go round another 360 degrees to get back to there. And if we do that, let's just add 360 degrees to that angle of 120 degrees, and that will get us another solution. So adding 360 to 120 gives 480, so pop 480 degrees in there. If I were to add another 360 degrees to the 420 degrees that we had here, I would get 780 degrees, and you can see that's out of range. So these are all my solutions. All I need to do now is just simply divide each one by 2. So if I halve the 60, that's clearly 30 degrees. Half of 120 degrees, 60 degrees. Half of 420 is 210 degrees. And half of 480 degrees is 240 degrees. And there you have all the solutions now between 0 and 360 degrees. I will point out one other common mistake that is made though. You'll find that you get some people who will come down here and they will write 2x equals 60 degrees, okay, as we had. Then they'll divide that by 2 and get x equals 30 degrees. And then they will draw their quadrant diagram, marking in the lines like so, and calling that angle 30 degrees and working off that as their x value. If you do that, you will be wrong. Okay, you'll get the first answer, 30 degrees, but then you'll go round there thinking this is 30 degrees in here, and come up with 180 take away 30, 150 degrees. And you'll put 150 there, and you'll notice it's not in the list. So don't make that mistake. As soon as you have 2x, or whatever angle you have here, and you inverse sine or inverse cos or inverse tan, make sure you do your full list at this point, then do whatever you have to do. In this case, divide by 2. Okay, so don't fall into that bad habit. So we'll just remove that, okay, and leave you with the solution.